Assalamu alaikum. In today's class, we are going to discuss about a consumer utility maximization subject to his budget constraint. As we all know, in the context of economics, that a rational consumer who is rational has always want to maximize his utility with the given resources or with the resources he or she have. So, how can he or she maximize his utility with the given resources? We can see in too many different ways. As far as the graphical representation is concerned, we can see that a consumer utility can be shown as different in different curves. We know that the higher the indifference curve, the higher the utility of the particular consumer or a person, individual. Same as if we talk about the resources, we can say that it can be shown as a budget constraint line or a budget line, which shows that this amount of the resources he or she may have. And now and then, what he or she will do, he as a rational consumer, he always wants to maximize, so he always want to attain the higher indifference curve subject to the particular budget line or a budget constraint. So in today's class, we will discuss about. We will not going to discuss the graphical representation of this theory. We will discuss the general notation and the mathematical functional form of this utility maximization. That how mathematically or how in the functional form a particular consumer may maximize his utility subject to the particular budget constraint. So let's start, and here we have a particular utility function. I select this red color. I think. Okay. So there is a particular utility function which we have. So the utility function is u is a function of x and y. So this is the particular utility function which a consumer may have, and it is a function of x and y. It means that there are two commodities. Okay, and now we also have a budget constraint. What is a budget constraint? We all know that budget constraint it has a particular formula which says that income is a function of price of x into x plus price of y into y, means that commodities and its particular prices, respective prices, when we sum both of them, uh, the value of the consumption of x and the value of the consumption of the second commodity, which is y, we can have many commodities when it comes to uh, uh, has come to spend his income, a consumer income. But in a limited discussion or in the context of economics, and to get a understanding, we only take two commodities, and also it is more convenient to plot that these two commodities on the graph. That's why we only take the two commodities. But in practical, we can have multiple commodities. Okay, now we have the budget constraint formula, which is income equals to price of x into x plus price of y into y. So this is our budget constraint, and the above one is our utility function. So we have to maximize. I may write here. Okay, that we have to maximize the budget, the utility subject to budget constraint. Okay, just ignore my writing because it's too messy, but still we can have some understanding. Okay, so this is our maximization function, and this is our subject. This is our constraint, you can say. Okay, subject to. So we have to maximize the utility and subject to the budget constraint. If we draw a little graph, we can say that there are only one budget constraint, but there are multiple utility functions. I think I have to rub it out because it's not tangent. So what I am saying is that yes, like this. So this is our first indifference curve, this is our second indifference curve, and this is our budget constraint. So we need to maximize the utility subject to the particular budget constraint. So we always, we are a rational consumer, we always goes towards the second indifference curve when we take this much commodity in order to maximize our satisfaction. Because higher the indifference curve, higher the utility a consumer has. Okay, now we start the general notation and we start to solve this. What are the steps? First, we have to transform the the constraint function, which is this one. So how can we transform? We make it equal to 0 like this: m minus pxx minus pyy. This is our step 1. Okay, equals to 0. This is our step 1, that income is equal to the expenditure. The income equals to we can say in the above function that income is equal to the expenditure, but here we can say that income, when we minus the all the expenditure, it becomes 0. It means all the income is consumed. Okay, so the step 2 is step 2 step 2 is that we have to write the Lagrange multiplier. Lagrange multiplier is a method to solve this kind of numerical, or we can say this kind of functional form, that how we can solve a particular maximization equation subject to some kind of formula, or subject to some kind of constraint function. So here we formulate the Lagrange function. It is like this: Lagrange, this is like symbol of Lagrange, and equals to the utility function, which is u is a function of x and y. It is okay. It is okay that if we write f here or not, because we can say, and a, a person who is well known with some kind of mathematical expression, he can easily ascertain that it is a function of x and y. So there now we write a sum plus sign, and then it is a lambda, which is called as Lagrange multiplier. It is the basically a Lagrange multiplier which we use before the our budget constraint. Our budget constraint which we formed in step 1: m minus pxx minus py. Okay. Now, what is our step 3? Step 3 is a little bit more, you can say that those who have some knowledge of calculus, they can easily solve it. That we have to write the first order condition. First order condition means we have to take derivative of 3 with respect to 3 variables, which are the first commodity, the second commodity, and third one is lambda. Okay, let the Lagrange multiplier. Okay, now we will start the derivative. Uh, it is basically the partial derivative. So we write here that that derivative of Lagrange. Uh, okay, so derivative of Lagrange with respect to, sorry, it is Dava. Okay, so with respect to x, what we write here, we can say that derivative of utility because there is x in it in a function derivative of utility with respect to x, and minus here. Here there is only x present in the bracket, which is multiplying, which is with the multiple of price of x, in multiplication of price of x. So what we write? We write this minus px and lambda, as there is no you can say that there is no x in income and there is no x in price of y and y. So we have only this particular expression written out, that px and x will become 1 because there is a rule of derivative which says that if we take derivative of any particular function, the power will come in front of that particular variable, and we will subtract 1 from that power, so it will become 1 x 0, it becomes 1. So that's why here x becomes 1, if we only left with price of x, and lambda, as it is outside from the bracket, we will multiply it from the remaining expression. Okay, in the same way, and it is always equal to 0, first order condition always equal to 0. In the same way, you can also you can also write the expression for y, and the same will occur here, that py with lambda. Same method will apply on this as we applied on x. Okay, now what we have to do? Okay, now we take first order condition with respect to lambda, and what we got, because as lambda I think that I have to show. Okay, now you can see that I made up this one. Okay, so as you can see that the when we take derivative of lambda, we only have the remaining bracket, which is m minus pxx minus pyy equals to 0. So this is basically the remaining function of lambda, which is in the bracket, and when we take derivative of lambda, derivative of Lagrange with respect to lambda, we got this. Okay, now what we have to do, we just have to write these both first and second equation. This is the first, this is second, and this one is our third equation. Now we only just transform these both equations with respect to you can say with respect to lambda. How I can write it? You can write them like this: derivative of u with respect to x, px lambda, and in the same way it becomes 4, and derivative of u with respect to derivative of y equals to p by lambda. We can solve it we can solve it uh, uh, by taking lambda on the one side and then equating lambdas, or we can also solve them by equating fourth and fifth equations together. So we have these both two options. So we are going to equate fourth and fifth equation together like this: fourth and fifth equation. Our so when we divide fourth equation with fifth equation, what we got? Derivative of u with respect to derivative of x, derivative of u with respect to derivative of y equals to px lambda upon py lambda. Lambda got cancelled, and we left with derivative of u with respect to derivative of x and upon derivative of u with respect to derivative of y, and equals to px over py. And we know that derivative of u with respect to derivative of x means that if x increases marginally, how much the units of utility will get increased. So this is basically the marginal utility of x, and this one in the same way becomes marginal utility of y. So we can say that the function, this function is basically mux upon muy equals to px upon py, and we all know in the context of economics that mux upon muy will become marginal rate of substitution. I am writing it here, marginal rate of substitution. So it will become mrs equals to px upon py. This is our final function. And also, what does it mean? It means that slope of indifference curve is equal to slope of budget constraint. And as initially I have told you that a rational customer will always want to maximize his utility subject to the budget constraint. It means that if we go the initial section of this lecture, this one, we can easily see here that what it is showing here, that we are selecting this indifference curve of number 2, which is just tangent to the budget constraint. And when both are tangent to each other, it means the slope of budget constraint and the slope of indifference curve at this point will become equal. And we can easily see that if we want to maximize the our utility subject to the budget constraint, we must have to make the slope of each item, which is indifference curve and the budget constraint, equal. So you can easily see it in here that here when we obtain the function, we can easily see that MRS, which is the slope of indifference curve, is just equal to the budget constraint, and this is the basically the general notation of how to maximize the utility function with respect to the budget constraint. In next class, inshallah, we will discuss about how we will just put some kind of function. It is a functional form, and we then put some kind of numerical example in which we have some different equations. So with the help of these equations, we will solve the same Lagrange multiplier and obtain, and we'll go forward, and we'll move more towards the different concepts starting from this point, which is MRX equal to PX and PY. We will move forward also, inshallah, with the help of that equations, and then in our another class, inshallah, in the next second or third class, inshallah, we will have some numerical function in which we obtain the exact number of values which is required to be consumed in order to maximize the utility with the given resources. Thank you so much.